Now we are going to discuss what are the electrolytes. So electrolytes are the substance that can conduct electricity when they are dissolving in a polar solvents like water. So the conduction of electricity or passage of electricity takes place because of the dissolution of that substance into polar solvents like water. So ultimately, when that substance undergoes into polar solvents, it becomes cations and anions. So what are the cations? The positive charge carrying species are called cations, and negative charge carrying species are called anions. So we have two types of electrolytes, and the first one is called strong electrolytes and another one is weak electrolyte. So general examples for electrolytes are acids and bases and salts. So according to their degree of ionization in a particular solvent, we will classify them as weak and strong electrolytes. So next we are going to discuss about what are the electrolytes and what is meant by weak electrolytes and strong electrolytes. So electrolytes are substances that can electrically conduct when they are dissolved in certain polar solvents. So when that substance is going to dissolve in a polar solvents, they become cations and anions. So the carriers for the electricity are those ions. So such a substance is called electrolytes, and some of them are very strong in conducting the current, or they can easily pass the electricity through it. So that kind of electrolyte is known as a strong electrolyte, or other words we can describe like that: the substance, the electrolytes that can completely ionize or dissolve in the solvents and form the corresponding solution. That electrolytes are called strong electrolytes. Generally, all strong acids, bases are examples for strong electrolytes. So here on the whiteboard, the electrolytes can be classified into the strong electrolytes. The strong electrolytes can completely form ions in a solution. So they are good conductor of electricity generally. And the examples are all the salts, for example, sodium chloride, or strong acids, hydrogen chloride, hydrochloric acid, bases, sodium hydroxide, etc. And the weak electrolytes are they partially ionize, they partially undergoes ionization. They are very feeble ionized substance, and they are very poor conductor of electricity, and they are known as weak electrolytes because their degree of ionization is less compared to the strong electrolytes. The examples for weak electrolytes are generally weak acids like acetic acid, CH3COOH, or weak bases like ammonium hydroxide. So we are considering an ionization of a weak electrolyte, and we are going to apply on that equilibrium the concept of law of mass action, and that concept is known as a Ostwald's dilution law. So the concept of law of mass action we are going to apply on a reversible equilibrium of weak electrolyte, And that mathematical representation of that equilibrium constant is known as a ionization constant or Ostwald's dilution law. So here we consider an equation. There is a weak electrolyte AB undergoes ionization. We get A positive and B negative cation and anions. And these ions are responsible for the conduction of or the passage of electricity through that solution. So here we consider the C. The letter C means the number of moles of that electrolyte per liter of the aqueous solution. And the alpha means the degree of ionization. So according to our equilibrium concept, AB undergoes to the products A plus and B minus. Similarly, this A and B combine to form the reactant AB again. So this is a reversible equilibrium reaction. So here we consider initially we have C number of moles of AB. So after some time there is some ionization takes place and the degree of ionization is alpha. So after some time we will get C alpha moles of A and C alpha moles of B negative. So after removing that C alpha from the initial concentration, we will get a C minus C alpha concentration of AB. So in that scenario, now we have C minus C alpha moles of AB and C alpha and another C alpha moles of B minus and A plus respectively. So here there's a common factor of C. We taken outside from the bracket, we'll get 1 minus C alpha. Sorry, 1 minus alpha because C gone outside. So we are taking C outside, so we'll get 1 minus alpha. That means C minus multiplied by C again C alpha. C minus C alpha. We get C alpha, the same thing, C alpha. So here we are applying the law of mass action. So what's the law of mass action? The equilibrium constant K is equal to the product of the active mass of products divided by the product of the active mass of the reactants. So here, according to law of mass action, the product of the active mass of reactants, products, divided by the product of the active mass of reactant. So we get active mass of A plus active mass of B divided by the active mass of AB. So the A plus is equal to C alpha, B minus is equal to C alpha, AB is equal to C bracket 1 minus alpha. So we substitute here, we got C square alpha square divided by C bracket 1 minus alpha. So there is a common factor C, so we cancel one C from the top. So we get K is equal to C alpha square divided by 1 minus alpha. So this is the mathematical representation of Ostwald's dilution law. So according to Ostwald's dilution law, for a weak electrolyte, the K, and here the K is known as a ionization constant of that particular electrolyte. So K, the ionization constant is equal to C alpha square divided by 1 minus alpha. And there C is the molar concentration of that electrolyte per liter of the aqueous solution. And alpha is the degree, the degree of ionization, how much ionized, how much substance got ionized into the products after some time. Thank you very much and God bless.